The FP7 project, under the acronym Senseiver, is a so-called ITN, or Initial Training Network Program. The project is funded by the European Commission as part of their Marie Curie actions, with a total budget of 3 million euros. 3 groups of researchers are each working on 3 major areas of the project, namely the synthesis of the necessary materials for sensor fabrication, the fabrication of sensors in LTCC technology or low temperature co-fired ceramics technology, and the design of integrated circuits for ultra-wideband transmitters. One of the main goals of the project is to create the conditions and carry out the training of 17 young researchers and 4 experienced researchers. I'm one of the researchers working on the Senseiver project. Currently, I am at the Vienna University of Technology's Institute for Sensor and Actuator Systems. My official title is Project Assistant. Our part within the Senseiver project is sensor fabrication. The project involves about 15 doctoral candidates from multiple centers across Europe. University of Novi Sad, Faculty of Technical Sciences, Serbia. Vienna University of Technology, Institute of Sensor and Actuator Systems, Austria. Georgia Saki Technical University, Iași, Romania. Institute of Electron Technology, Krakow, Poland. University of Porto, Institute of Systems Engineering and Computers, Portugal. TES Electronic Solutions, Stuttgart, Germany. North Point Limited, Subotica, Serbia.
Within Project Senseiver, I am working in Portugal as an early stage researcher. Here my job is to design ultra-wideband transmission system. Basically, I am working on the radio frequency side.
I work as an early stage researcher for the University of Iași in Romania. And my work is focused on the electric characterization of sensing materials, but I'm also working on the simulation of sensing systems.
The work we are doing for the Senseiver project at INESC Tech Porto relates to the third major area of the project, namely the transmission of data acquired by a sensor to a base station for further analysis. The technology we are using for this is ultra-wideband, and we are designing and building the appropriate infrastructure that will allow data transfer from the sensors to the base station. Why ultra-wideband? Well, the amount of data comes from the sensors relatively slowly, because environmental changes are usually not abrupt, and this allows us to use an impulse radio ultra-wideband technology that is very energy efficient. This is crucial for having sensor nodes that are autonomous and do not require extensive human intervention, such as replacement of batteries needed to power the transmission circuits. So this is what our 2 researchers are working on. One is more focused on the transmitters and the other one on the receivers.
The Senseiver project is a very interesting new opportunity for a company like TES Electronic Solutions, since we are a technology developer and service provider for many companies in Western Europe. Here in Germany, in South German region, our customers are using our products and developments in many applications like aerospace, automotive, industrial, medical. So we are very keen and very interesting always to get along with newer developments and to get cooperation with new and interesting people from university, and therefore the projects like Senseiver, where the initial training networks are connected together with the development of new technologies, are really interesting and exciting for us.
I live and work in Stuttgart, Germany, and I'm a part of the Senseiver project at the TES Electronic Solutions company. At the TES Electronic Solutions company, I gained a lot of practical knowledge, and I feel better prepared for industrial production and finished product design.
I came from Iran, and I'm working as an ESR early stage researcher in University of Porto. Our duty in this project is to design a low power transmitter for LTCC sensors.
I'm coming from India, working in Poland, Krakow, in Marie Curie, one of the Marie Curie Senseiver project. You know, in our present situation, one of the major issues is water pollution.
I come from Novi Sad, Serbia. Currently, I am employed within Senseiver project as an early stage researcher in Poland, Krakow. I work at the Institute of Electron Technology, and my goal within this project is to synthesize novel materials for gas sensor applications.
I'm coming from India.
I come from India, where I completed my academic and master studies in chemistry at the Mahatma Gandhi University. For the past 2 years, I have been working on the Senseiver project. I'm working on the Senseiver project at the North Point company in Subotica. I deal mainly with measurement and data acquisition systems. My role in the project is sensor characterization and testing.
My responsibility
is to synthesize materials for the fabrication of LTCC sensor coatings, which are used to monitor toxic gases in our environment, gases such as carbon dioxide and carbon monoxide. The plan is to develop very cost-effective sensors in the so-called LTCC technology. This is a robust ceramic technology used to develop sensors for monitoring environmental parameters. With these sensors, we can monitor the presence of pollutants in the air, water and soil. We specifically deal with manufacturing 3D sensor structures that contain channels, heaters, electrodes and materials sensitive to pollutants in the air, water and soil. Our task is to bring all these things together and integrate them into a compact structure, which will later provide a quick, simple and reliable way of measuring and detecting pollutants in the environment. What we have developed so far are two systems that can acquire data about relative humidity and temperature from a commercial sensor. Our plan for the next stage of the project is to use this system with the sensors developed by our partner institutions. The system you see here is connected to a commercial sensor that measures temperature and relative humidity. They are connected via a serial port, and the data is read by the LabVIEW application, which we can run on our computer. The software was developed by our colleague Mariana from TUI Romania during her stay in Subotica. These two synthesized materials are gas sensitive. Such oxide layers are synthesized in various ways. This sensor was fabricated on an LTCC substrate. During the first half of the project, our young researchers and their mentors have published 11 papers in scientific journals and 32 papers at international conferences, 4 of which have been awarded as the best in their conference sessions.
Neki od njih, tačnije 4 naučna rada su bila i na konferencijama i nagrađena kao najbolji naučni radovi u tim konferencijama, odnosno u ovoj oblasti.
The basic idea of the Senseiver project is to develop cost-effective sensors in the LTCC ceramic technology. The 3 institutions involved in this project, namely the Vienna University of Technology from Austria, the Institute of Electron Technology in Krakow, Poland, and more recently the University of Novi Sad, Serbia, all possess cutting-edge equipment for manufacturing sensors in LTCC technology. The transceivers will be developed in CMOS technology, while a third group of researchers is working on developing materials for coating the sensors developed in LTCC technology. This completes the entire system for monitoring environmental parameters. The University of Novi Sad possesses modern equipment for flexible technology, namely the Dymatics printer, and we also have modern equipment for the characterization of fabricated sensors and designed chips.
karakterizaciju fabrikovanih senzora i isprojektovanih čipova.
Proiectul Senseiver reprezintă o șansă de a îmbunătăți cunoștințele.
The Senseiver project is an opportunity to improve the process of sensor production in LTCC technology, as well as a chance to improve a person's scientific career.
O carieră în știință.
16 early stage and 4 experienced researchers are involved in the Senseiver project. In accordance with the mobility rule, 14 researchers have moved from one European country to another, while 2 researchers from India, 1 from Iran, and 1 from Pakistan have moved to Europe. Out of 20 researchers involved in the Senseiver project, 7 are female. They will be involved in this project for a maximum of 3 years, and during that time, some of them will have the opportunity to defend their doctoral dissertations.